Assalamu alaikum. Welcome to my channel M.Asif Math Corner. Today we will discuss about cosets, what are left cosets and what are right cosets of subgroup in group theory. Let's start. Definition. Let H be a subgroup of group G and A belongs to G. We take the element for cosets from the whole group G and we multiply or add in subgroup which is H in left side and right side and check either the group or set come after this action belongs to G or not. If belongs to G, it must belongs to G and that will be the cosets of G. So if we take A from G and put and multiply subgroup H from left side and it give us AH where H belong to H and this is left coset. This is called left coset. If we take an element, for example A belongs to G and multiply H by right side and HA where such that H belong to subgroup H, then it is called right cosets. For example, if we take identity element, in multiplication we know that identity element is 1. If we 1 multiply all the elements of H from left side or right side, it give us H itself. The identity element multiplied by left side, all the elements of H, so it give us H itself. And when we multiply identity element with all the element of H from right side, it gives us also H element, because identity element, when we multiply any identity element to any other element, then the answer will be that other element, not identity. So this was multiplication and same action will be done for the addition. We will discuss two examples with respect to addition and with respect to multiplication. By those examples you will clear the cosets, left cosets and right cosets very easily. Let's come to the first example. The first example is, let we have a group Z6 residue classes under addition modulo 6. These are the remainders. Then we take a subgroup H from Z and we can check easily that it is either a subgroup or not. Because it is with respect to addition, then add all the elements, add 4 by 2, it gives us 6 and it is modulo 6, then 6 divided by 6 has 0 remainder, so 0 is here. And if we add 2 by 4, same answer. When we add 2 and 0, it gives us 2, and when we add 4 and 0, it gives us 4. It is mean it is closed, and we know that when we add 2 plus 4, it gives us 0, which is identity. It gives us 6, but the modulo is 6, so the remainder is 0. So it 2 plus 4 give us 0. It means 2 and 4 are the inverses of each other and 0 is identity element. So identity exists, inverses are exist, it is close associative also hold in general. So it is a subgroup. When we take one element, for example 0, from Z and add in all the elements of H, 0 plus 0 give us 0, 0 plus 2 give us 2, 0 plus 4 give us 4. It means H itself comes. Now second, when we add 1 in H, so 1 plus 0 give us 1, 1 plus 2 give us 3, 1 plus 4 give us 5, and other coset. One coset is this and other coset is this. We have two left cosets, and now check 2. When we add 2 in 0, it gives us 2. When we add 2 in 2, 2 plus 2, it gives us 4. When we add 2 in 4, it gives us 6. So modulo, due to modulo 6, it gives us 0. It means that it is the same set, which is H. So the quantity of cosets does not increase due to 2. Then you may check 3. Add 3 in 0 give us 3. When we add 3 in 2, 3 plus 2 give us 5. When we add 3 in 4, it gives us 7. When we 7 divided by 6, the remainder is 1, which is this. So uh, this 3 give us this coset. Similarly, this 4 give us this coset. This 5 will give us this coset. So the Z6 has only 2 cosets. Because Z6 is commutative or abelian, so left cosets and right cosets will be same. Let's come to the next example, which is with respect to multiplication. I hope you understood very easily by this example. Let's check the example with respect to multiplication. Let G is equal to 3 is equal to 3, 1, 3, 5, 7 are the elements of G. Be the group of residue classes under multiplication modulo 8. Modulo 8 means when we divide any number by 8, the remainders are these. The multiplication table of G given. It is easy to see that H1 is a subgroup of G, H2 is a subgroup of G, and H3 is a subgroup of G. We can check when we multiply 3 by 3, it gives us 9. When we 9 divide by 8, it gives us 1, and 1 is here. So 3 is itself inverse and identity element is 1. Similarly, 5 is itself inverse, identity element is here, and 7 is self inverse and identity element is here. So these are the subgroups of G. Now we check their left and right cosets. First we check the left cosets. When we take 1 from G and multiply it, the first element of H1, 1 multiply 1, it gives us 1. When we multiply 1 by 3, it gives us 3. It means when we multiply 1 H1, it gives us H1 itself. So when we multiply 3, when we multiply 3 by 1, it gives us 3 element. When we 3 multiply by 3, 3 3s are 9. When 9 divided by 8, which is modulo, it gives us remainder 1, and 1 is here. It means that by 1 and 3 we have one coset, one left coset of G. Now multiply 5 by 1, it gives us 5, and multiply 5 by 3, 5 3s are 15. When we divide 15 by 8, it gives us 7. 7 is here. It means that the 5 element give us this coset, this left coset. Now for 7, when we multiply 7 by 1, it gives us 7. When we multiply 7 by 3, it gives us 7 3s are 21. And when we 21 divided by 8, 8 2s are 16, and remainder is 5, and 5 is here. It means that these 5 and 7 give us this coset, and 1 and 3 give us this coset. There are two left cosets of G in H1. Now let's check H2. Similar process will be done by H2. Multiply 1 by 1, it gives us 1. Multiply 1 by 5, it gives us 5 H2 itself. And multiply 3 by 1, it gives us 3. Multiply 3 by 5, 5 3 are 15, remainder is 7. So these are two left cosets of G in H2. Similarly, H3 has two left cosets of G. So left and right cosets are same here. Therefore, notes that the union of cosets H1 5H1 is G itself. This is very important thing. Union of all cosets, union of this and this. Take the union of this and this. Any two. Union of this 1 7 and 3 5 make complete G. Union of 1 5 3 7 make complete G. Union of this 1 3 and this 5 7 complete. Make complete G. It means that these all cosets are the make the partition of G. Word used here, partition of G. About partition, our next lecture will be about partition of G. Here the lecture ends. I hope you understood. If you like my videos, then share it and subscribe my channel. Thank you so much.